problem number 7. There are different options for working these. I always check to see, are there any obvious identities to begin with? Okay, there's a Pythagorean identity. 1 plus cotangent squared is what?
Cosecant squared.
And then if you don't know what to do, what should we always...
Turn it into sine.
So tangent is sine squared theta over cosine squared theta. Cosecant is
1 over sine squared theta.
when you're multiplying, if you have the same thing on top and bottom, they cancel. So we get 1 over cosine squared. That wasn't the only way to do it. You could have gone to sines and cosines at the very beginning and then distributed your tangent through. You should get to the same point at the end. Number 8. Any obvious identity here?
No.
So what can we change cosecant to?
1 over sine.
And secant?
1 over cosine.
In order to add fractions, what do they have to have?
Common
Common
denominator.
denominator.
So we're going to take this one times cosine squared on top and bottom. And this one gets sine squared. So 1 times cosine squared is cosine squared. Over sine squared, cosine squared. 1 times sine squared is sine squared. Over sine squared, cosine squared. If your denominators are the same, then you can add them together and make one fraction. Denominator doesn't change. Cosine squared plus sine squared is 1. Okay, you might have left it like this, but you could have recognized, we've had some where we split this up and we said, well, this is the same as 1 over sine squared times 1 over cosine squared. 1 over sine is cosecant, and the square would just carry down. 1 over cosine is secant, and the square carries down. So this turned into cosecant squared times secant squared.
Is it okay if we leave it in the fraction? You want to?
I would prefer if you have 1 over something, write it in terms of the reciprocal. Is that one okay? So number 9b. Tangent of pi over 12. We need that to be in degrees. So we take it times 180 over pi. Pi's cancel. 180 divided by 12.
15.
Okay. So we need 2 angles that add or subtract to 15. What did you do?
60 minus
45 and 30.
Okay. I did 45 minus 30 on mine. I heard somebody say 60 minus 45 first. Doesn't matter. They'll both get us there. You could even do like 135 minus 120 if you wanted to be creative. Lots of options. So, go to your flip chart. Everybody get that out. We have a difference, so we're looking for the tangent difference formula. And it says tangent of A minus tangent of B. So my A here is my 60. My B is my 45 over 1 minus tangent of the first times tangent of the second.
I thought that was 1 plus because it was minus.
Oops, yes. Thank you. Okay. What is the tangent of 60? Minus, what is the tangent of 45? Over 1 plus, what is the tangent of 60? And the tangent of 45? This is not the same as the answer I gave because what did I tell you when I was going through that one? If you picked different angles, it will look different unless we fully rationalized all the way to the end. And did I require you to go that far? No. So when I was telling you the correct answer, the one I got, I did 45 and 30. Tangent of 45 is 1, tangent of 30 is radical 3 over 3 over 1 plus radical 3 over 3 times 1 is radical 3. And I got here. Now can you leave a fraction in a fraction? No. So I took everything times 3. And I got 3 minus radical 3 over 3 plus radical 3. These look different, but they're actually equivalent. You could confirm that by either rationalizing and getting the radical off the bottom, or looking at the decimal versions. I told you on these, as long as you get rid of the fraction and fraction, I would let you leave it like this. You just have to show me your work.
So we can't multiply by the 100?
You can if you go all the way to rationalize. I just told you when we did them, I wasn't going to force you to. Is that one okay? Alright, so cosine of negative 7 pi over 12. Change 2 degrees, 180 over pi.
You can have the
So, negative 7 times 180 divided by 12 is negative 105. You could, couple different options. You could add 360 and deal with the positive, or you could try to find two angles that add up to a negative 105, or subtract a negative 105. What'd you do?
Doesn't the negative just go away?
Or if you recognize the cosine negative angle identities, this is the same as the cosine of positive 105. Okay, any of those work. There's lots of different options here. So which one do you guys want me to do? Yeah, the 360.
255.
Okay, I need two angles that add or subtract to 255. So the cosine formula is cosine of the first, cosine of the second, minus sine of the first, sine of the second. What quadrant is 225? Reference angle.
45.
In quadrant 3, cosine is negative, cosine of 45, radical 2 over 2. Cosine of 30 minus, in quadrant 3, sine is negative, sine of 45, radical 2 over 2. Sine of 30, 1/2. If you multiply these, negative radical 2 times radical 3 is negative radical 6 over 4, minus negative, so plus radical 2 over 4. Okay, you could have them flipped, you could write it as one fraction. That part doesn't matter as long as you have all of this. Questions there? Next one. Problem 11. We have cosine squared 7x minus sine squared 7x. So I'm asking you to use an identity, or to simplify this. I guess I just said simplify, but we don't know 7x, so we're not going to be able to get like a number answer here. Look at your flip chart. You are looking for something that involves a cosine squared and a sine squared.
Cosine 2.
Okay, we have a formula, cosine 2a, which is cosine squared a minus sine squared a. So if I look at this, it is the right-hand side of the formula. So you're giving me the left cosine of 2 times A. A is just your angle, so 2 times 7x. So that's the cosine of 14x. And that's all you can do. We don't have any numbers. We can't get a number answer here. Number 12. I'm giving you cosine 2x is negative 3/4, and x is between 0 and 90. What quadrant is that?
First.
Notice the difference. This is for the angle x, but this is for 2x. So I'm asking you to find sine of x and cosine of x. I know my cosine 2x. We have 3 different formulas. So we just have to pick a starting point. If I wanted to find sine, cosine 2x, look at your formulas. Which one involves only sine? Okay, so my cosine 2x is negative 3/4. So if we subtract our 1, that would give us a negative 7/4. Divide by negative 2. So sine squared x equals 7/8. How do we get rid of a square? Square root. With that you would do plus or minus, but I know x is in what quadrant? So sine is positive in quadrant 1. I don't know the square root of 7. 8 I could break into 4 and 2, so 2 radical 2. Get your radical off the bottom. Get radical 14 over 2 times the square root of 4, so 2 times 2, which is 4. Alright, once you have sine, or really once you get one of them, you have 2 options for the other one. We could create a triangle for x now, or we could just use the formula, a double angle formula again, and do the exact same thing. You guys have a preference? Okay, so I'll show both ways. I had a request for double angle, and also a few of you said the triangle way. So if you did the double angle, you would use the 2 cosine squared x minus 1. Cosine 2x is negative 3/4. You would add your 1 over, divide by 2. To get rid of a square, use square root with that plus or minus, but we know we're in quadrant 1. It's a positive. Square root of 1 is 1. 8 breaks into 2 radical 2. If you multiply by the square root of 2, you get the square root of 2 over 4.
We did it after you find cosine for triangles.
Yes. After you find 1, you are welcome to set up a triangle. We know that x is in quadrant 1, so you use your SOHCAHTOA. If I found sine, sine is opposite, so my opposite side is radical 14 over hypotenuse. Then you could do a squared plus b squared equals c squared. So b squared equals 2, square root, since we're in the first it's positive, you get your radical 2. So then cosine adjacent over hypotenuse is radical 2 over 4. Let's look at problem 13. This time, I gave you cosine of regular x. Okay, and information about sine. Cosine is positive, so we know that could be 1 or 4. If sine is also positive, which quadrant was it? So cosine is adjacent over hypotenuse. So we can find the missing side. Square root, that does not reduce. We just get the square root of 22. So I asked you to find sine and cosine of 2x. So sine 2x, there is only one formula for it. It is, notice, sine of x and cosine of x, so we can use triangle x for those. Sine, opposite over hypotenuse, radical 22 over 5. Cosine, adjacent over hypotenuse, radical 3 over 5. When you multiply, any numbers under the radical stay under the radical, things outside the radical stay outside. So the 2 stays out. Radical 22 times radical 3 becomes a radical 66. 5 times 5 is 25. Can we break down radical 66? No. So that is our answer. Cosine 2x we have 3 different formulas for, so you pick one. Let's say I did 2 cosine squared x minus 1. What is cosine of x?
3.
Okay, so if we square that, radical 3 squared is 3, 5 squared is 25. We get 6 over 25 minus 1, or negative 19 over 25. If you're struggling, I strongly recommend writing down the formulas that you're trying to use. It will help you a lot to see what you have and what you need to plug in. Anything else I need to talk about? Okay, let me get through those and then I'll backtrack to it. Right, then we got into our proofs. Okay, I really want to stress, if you did it a different way than I did, it doesn't mean you did it wrong. Okay, there are multiple ways to do most of these problems. We just have to pick a point and start there. So we start by boxing in a side. Not necessarily a right or a wrong, just sometimes one's easier than the other. Which one did you box in? Okay, look at what we have. Our goal is to only have cosines. So when I'm looking at this, I'm thinking, okay, that's sine squared, that's secant, those need to go. Okay, so lots of different options here. If you recognize it, cosine squared x minus sine squared x is cosine 2x. That works. What would we do with secant?
1 over cosine.
How do you divide fractions?
Flip and multiply.
It's like cosine 2x times cosine x over 1. Okay, I'm doing good in that I have cosines, but if you look at your goal, do we want any double angles? So what could I change cosine 2x to? That only has cosines.
2 cosine squared a minus 1.
And we still have this times cosine x. Then if you distribute, you get 2 cosine squared x times cosine is cosine cubed x. Minus 1 times cosine x is cosine x. Definitely not the only way to get there, but it worked. Is that one okay? Problem 15. 2 tangent b over sine 2b equals secant squared b. Which one did you box in?
The right part.
Right.
Okay, so when I'm looking, I'm probably going to go to sines and cosines, look for any formulas that we can do. The first thing I notice is this is a sine of 2b. Do we have any other double angles in our problem? So let's change that. What can you change sine of 2b to?
Two sine B, cosine B.
Then what happens?
Can you choose cancels?
Oh, yeah.
All right, tangent. We can change that to sine over cosine. And we still have our denominator. All right, not proper notation to leave a fraction in a fraction. How could I get rid of it? Okay, 2 options. You could think of this as over 1 and flip and multiply. Or you could just say, you know what, I need to get rid of a cosine, so I'm going to take top and bottom of my fraction times a cosine. We've used both of those strings. Those cancel and we get sine. In the bottom we have a sine times cosine is cosine squared. Sines cancel. We have 1 over cosine squared b, which is secant squared b, and that's what we want. All right, is that one okay? Number 16. All right, we have to box them aside. Which one do you want to do?
Left.
All right, I agree. That right-hand side's kind of ugly. All right, where do you want to go with the left? Lots of options.
Change the bottom of the secant squared B.
Okay, you could recognize that Pythagorean identity. The other option would be to go to sines and cosines. I heard both options shouted out. Do you guys have a preference? Sines and cosines?
I don't know what I did. Somehow I got one on top.
Well,
Because I split it up.
I did what you did correctly.
Oh, I see what I did.
Okay, not proper notation to leave a fraction in a fraction. What's the fastest way to get rid of it?
All by cosine.
So 1 times cosine squared theta is cosine squared theta. Sine squared over cosine squared times cosine squared.
Sine squared.
Okay, on the bottom, 1 times cosine squared is cosine squared. Plus sine squared over cosine squared times cosine squared is just sine squared. Okay, again, different options from here. We should all recognize the denominator. Cosine squared plus sine squared is 1. The numerator, you may or may not recognize. This is a double angle formula. So you could turn it into cosine 2 theta. The other option, if you look at your goal, the only thing we want is the cosine. What can you change sine squared to?
Cosine minus, or 1 minus cosine.
From my favorite Pythagorean identity. So just different options, they're all going to get us there. If you have that negative, you would distribute it. Cosine squared plus cosine squared is 2 cosine squared. plus a negative 1 is minus 1, and the divided by we could drop, and that's what we wanted. Or if you had gone into the cosine 2 theta, you would write cosine 2 theta and then use the other cosine 2 theta formula, which was this.
I turned my denominator from like the get-go, I turned the 1 plus tangent squared into secant,
Mm-hmm.
and then, I don't know, I started because I didn't know if I was able to, like, there was a multiplying thing. that I
So,
figured.
it would be a 1 over secant, and then you could,
Oh,
you split them up, put each one over that, so 1 over
I
secant
just
is
like
cosine.
skipped a step.
Okay. Yeah, that works.
But I started
I just
adding
went
here.
straight from
Because
here
you
to the other one.
had a changed your tangent, split it
Yeah.
to secant squared minus 1.
Yeah.
And then just put it in front, which would be your secant squared plus 1. Let's look at problem 18. Okay, definitely not beautiful. Which side do you want to box in? Okay, on the left, if you want to add or subtract, what do we need?
Like the common denominator.
Alright, so this one has 1 minus cosine, it needs 1 plus cosine theta. So we'll do it on top and bottom. This one has 1 plus cosine, so it needs 1 minus cosine on top and bottom. So if we distribute, we get sine theta plus sine theta cosine theta over, if you FOIL, this 1 minus cosine squared. Over here, sine theta cosine theta minus sine theta cosine squared theta over 1 minus cosine squared theta. Once you have a common denominator, what can we do?
You can add them all.
We can put them
You
together. Okay, so we're going to make one big fraction. Because this was a minus, we have to distribute that. Sine, cosine, and negative sine, cosine drop. We're actually not too far. The denominator, 1 minus cosine squared, like Carson said, that is sine squared. If you look at where we're going, we want things factored. What could I factor out of the top?
Take out a sign.
So that would leave us 1 plus cosine squared theta. If we have a sign on top and bottom, we could cancel one of them. You don't necessarily have to show this step, but this is the same as saying 1 over sine times the 1 plus cosine squared theta. And 1 over sine is, and that was what we were trying to prove. If we ever get stuck, we also know what option do we have.
Put it all into sine cosine.
And we can also, if we work this side, maybe we got to here and we didn't know what else to do. Could we box it in and go work the other one? Yes, you're just trying to make them match. All right, problem 19. Tangent theta, sine 2 theta equals 2 minus cosine squared theta. Okay, now
2 minus 2 cosine.
thank you. There's not one side that's obviously easier. However, what sticks out to me is those angles are different. So if you have different angles, it might be easier to work with that side because we know we have a formula for the cosine 2 theta. What can I change tangent to?
Well, cosine over cosine.
2 what can we change sine 2 theta to?
Two
Cosine,
sine,
cosine.
cosine, 2 sine theta, cosine theta.
Had to add that theta.
Okay.
Yes, because that's the formula.
If something is on both the top and the bottom, they can cancel. So at this point, I have 2 sine squared theta. You might know what to do from here. You might be stuck. If we're stuck, we know we could box it in and go work the other side. If you recognize it, we want something involving cosines. What can we change sine squared to?
1 minus cosine squared theta.
So if we distribute, that gives us 2 minus 2 cosine squared theta.
Alright.
Mhm.
So I boxed in but
Okay.
I got to 2 sine squared theta.
You get, okay. So you took out the 2, 1 minus cosine squared. So that's sine squared theta. From there, it is going to be kind of hard to know where to go. You're going to have to start introducing some stuff into your problem. So you would probably either jump ship and go work the other side and try to make them match now, or realize you're trying to get a tangent, and tangent is sine over cosine, right? So you could think of this as over 1 and say, okay, well I need a cosine on the bottom, so I can put 1 on both top and bottom. So if we do that, we have a 2 sine squared theta cosine theta over cosine theta. If you took out a sine on the top, then you have 2 sine theta cosine theta. And I'm going to put my cosine here. So sine over cosine is tangent. 2 sine theta cosine theta is sine 2 theta.
That's my.
I'm gonna go the other way.
That's the way I've always wanted to work out problems, but I just it's so much
When you
more
have to
complicated.
add things in, it gets tricky.
Yeah, but you get to know what like if you
Yeah,
need
the
something.
more you do it, you'll know, oh, I need this.
if you need
so-
a cosine, you know you can just throw one in there the right way, not illegally, but you know.
This math is crazy.
Okay, number 10. This is a cosine difference problem. So the formula is cosine of the first, cosine of the second, plus sine of the first, sine of the second. What quadrant is 135?
So that would be the second.
Reference angle, 180 minus 135 is 45. And quadrant 2 is cosine positive or negative.
Negative.
And cosine 45,
Radical Z over 2.
yeah, that's a, I don't know what I was starting to write there.
That's how some of my 2's do be looking like Z's sometimes.
And we can't do cosine x. In quadrant 2 is sine positive or negative.
Positive.
And the sine of 45?
Also radical 2.
The directions said to write it with only x as the argument. That means any trig functions you have left have to have just a plain x, nothing added or subtracted. So that's as far as we can go. You could factor out like a radical 2 over 2 and put that in front and then like sine x minus cosine x in a parenthesis, but you don't have to.
Okay, that's what I have.
Yeah, that's equivalent. Are there any other? So problem 20, we had 2 cosine, just making sure I whited out and changed my original problem. I want to make sure I changed my numbers. Sometimes I write one and I work the whole thing out and then I decide to change the question. I don't want to make a whole new answer key. So I just white something out and change it. Okay, which side you box in? Yeah, it could be either. When I look at this, my left has double angles. We have formulas to get rid of those, so I would probably box in the right. Cosine 2a, so that 2 in front would just stay. Cosine 2a, we really have 3 different formulas for. If you look at where we are going, we have a cotangent and a tangent. That means I need both sines and cosines. So I would pick the formula that involves both of them. On the bottom, sine 2a we only have 1, 2 sine A cosine A. What happens to my 2's in front?
Cancel.
The bottom is a single term,
Split it
so we can break this apart, put each one over the denominator. So then if we reduce cosine squared, we can take one of those out. Cosine over sine is cotangent. This one we can reduce a sine, and we have sine over cosine, which is